due to climate change. More than 20 million have been displaced as climate refugees. Scientists also worry about the billions of tons of methane sitting beneath the now melting Arctic permafrost and the ever-warming oceans.
Warming Oceans, a call to end the climate crisis. Part 1 of 3. Continue watching to find out more. Drin Gwinzi means good day in Gwich'in, one of the Aboriginal languages spoken in the Yukon Territory. I am Quiche. The caring people of the Yukon Territory are grateful to you for being good environmental stewards and for choosing to be vegan. Earth-loving viewers, welcome to part 1 of our 3-part series, Warming Oceans, a call to end the climate crisis. In this episode, we'll explore melting sea ice and permafrost and how these phenomena are related to the warming oceans. Today, the planet is facing critical climate challenges due to human activities that are detrimental to the environment and our animal co-inhabitants. Raising animal livestock is recognized as a leading cause of human-driven greenhouse gas emissions, deforestation, and air and water pollution. Ocean warming is accelerating due to excessive amounts of greenhouse gases in the atmosphere that prevent heat radiated from the Earth's surface from escaping into space.
Arctic ice reflects sunlight back into space, keeping the planet cool. As the ice melts, the reflecting white ice is replaced by dark water which absorbs sunlight. This heat makes more ice melt, which in turn allows more heat to be absorbed in a positive feedback loop. Another problem is that as the frozen northern marshy regions melt, methane, which is also a greenhouse gas, previously locked in the ice, is released, adding to the gases in the atmosphere, thereby causing more warming.
British glaciologist Dr. Julian Dowdeswell explains how the melting of sea ice affects warming temperatures.
Sea ice covers up to 20 million square kilometres of the polar seas during winter. That's about double the size of Europe. On the other hand, the glaciers and the ice sheets that cover large land areas of the Earth's surface are up to kilometres in thickness. Glaciers are a few hundred metres thick. The great ice sheets of Antarctica and Greenland are up to 3 and 5 kilometres thick, respectively. If all that ice on land were to melt, global sea level would rise by about 60 metres, or perhaps even a little more.
As the oceans continue to absorb large amounts of heat, their surface temperatures are rising. And as the ocean surface warms, it has an enormous impact on marine life, storm intensity, and more. An international team consisting of 14 scientists from 11 institutes conducted a comprehensive study entitled Record-Setting Ocean Warmth, continued in 2019. The study revealed that in 2019, the world's oceans were the warmest in recorded history, and that the rate at which ocean temperatures are rising is speeding up. The findings, published in the January 2020 issue of the journal Advances in Atmospheric Sciences, reported that the average ocean temperature in 2019 was 0.075 degrees Celsius above the 1981 to 2019 average. While that may sound minuscule, it represents an enormous amount of heat absorbed by the world's oceans. Regarding this issue, climate research scientist Dr. John Abraham says, "It is critical to understand how fast things are changing. If you want to understand global warming, you have to measure ocean warming." Similar to heat waves on land, extreme heat can also affect the near-surface layer of the oceans, with a wide range of consequences for marine life and dependent communities. Sea surface temperatures and marine heat waves are currently being tracked by satellite. Marine heat waves are categorized as moderate, strong, severe, or extreme. During 2020, much of the ocean experienced at least one strong marine heat wave at some point. Co-chair of the Intergovernmental Panel on Climate Change, Dr. Hans Otto Portner, reiterated the severity of the warming oceans. The oceans are sending us so many warning signals that we need to get emissions under control. Ecosystems are changing, food webs are changing, fish stocks are changing, and this turmoil is affecting humans. In addition to ocean warming, sea levels are expected to rise significantly by the end of the century, putting coastal regions at extreme risk. Professor Portner further warned, "We should all be concerned because the oceans are covering more than 70% of the planet, and sea level rise concerns many coastlines, especially the low-lying coasts and the low-lying islands. There is no time to wait." We'll take a moment now to pray that all human beings soon adopt a vegan lifestyle to help stop climate change. We'll be back after this message. Please stay tuned to Supreme Master Television. Thoughtful viewers, welcome back to our program. Warmer ocean temperatures are causing the melting of Arctic ice and permafrost, thus releasing large amounts of methane gas into the atmosphere. This in turn causes rising sea levels, which pose a profound risk to the hundreds of millions of people and animals living in coastal areas.
Temperatures have been rising over the past century, and they've been accelerating in that rise since 1980. Global temperature has risen at least half a degree since the 1960 to 90 period. Sensitivity is high in the Arctic because reflective sea ice is being replaced by open water, and there's a self-reinforcing process, which means that the energy balance is changing, and therefore less sea ice produces more warming of the water. We see this in this image here, where in the 40 years over which satellites have accumulated data, the amount of sea ice present during summer has dropped by almost a third. That's about half the size of Australia is now open water instead of very reflective ice, and that makes a big difference to the energy balance. There are three controls on global sea level. The first is melting of glaciers and ice sheets. The second is the thermal expansion of the ocean. And the third is changing storage of water on the Earth's surface.
The greatest influence on sea level rise is the melting of Earth's massive ice sheets on Antarctica and Greenland. If completely melted, these ice sheets contain enough water to raise sea levels by several meters. Even if just 10% of these ice sheets disappeared, it would flood numerous coastal cities and submerge many small island nations, rewriting world maps. And a dangerous amount of melting is already occurring. In 2019, record heat triggered extreme melting in Greenland. By the end of summer, it was estimated that more than 400 billion tons of ice had either melted or calved off of Greenland's giant ice sheets. That would provide enough water to cover the entire state of Pennsylvania, USA, or all of Greece with about 35 centimeters of floodwaters. In a 2018 presentation by the USA's National Center for Atmospheric Research, or NCAR, Dr. William Lipscomb, a senior research scientist at NCAR's Climate and Global Dynamics Laboratory, spoke about the impact of melting ice sheets.
If you have warming of, let's say, 3 degrees Celsius, a little over 5 Fahrenheit or more, the Greenland ice sheet is probably not viable, but most of it would melt. And the West Antarctic ice sheet would probably collapse at some point. And maybe you'd lose significant parts of East Antarctica as well. And so you'd get sea level rise of at least 12 meters and maybe more like 20. And that would be pretty well catastrophic.
Hotter ocean temperatures combined with rising sea levels further imperil marine ecosystems and coastal regions. The warmer ocean also causes extreme storms and the changing of traditional weather patterns. Nations must quickly take the necessary steps to reduce greenhouse gas emissions and halt climate change. To stop climate change, we must understand its root cause. Numerous studies around the globe have concluded that the primary cause of greenhouse gases is the raising of livestock. The United Nations also reports that raising livestock contributes more greenhouse gases than all forms of transportation combined and recommends a widespread shift to a plant-based diet. Our beloved Supreme Master Ching Hai has spoken many times about the risk posed by rising sea levels and the devastating consequences we face as a result. She reminds us that the fastest way to halt climate change and prevent further catastrophic events is through the organic vegan lifestyle.
According to the latest report,
sí, porque de acuerdo a los reportes más recientes,
animals is responsible for 51% at least of all the greenhouse gas emission that heat up the planet.
Los animales son responsables por lo menos del 51% de los gases de efecto invernadero que calientan nuestro planeta.
So if we stop animal industry, we cut out 51%
Así que si eliminamos la industria animal, eliminamos el 31%
of the heat.
del calor. Claro.
It's fuzzy.
Easy.
And then, if we use all the tillable land, all the cultivable land to plant organic vegetable and fruit.
Y entonces si usamos toda la tierra disponible arable que se usa para los animales para plantar orgánico,
then we cut off another 40% at least of carbon dioxide that exists.
entonces eliminamos por lo menos otro 40% del dióxido de carbono que ya existe.
The planet cool off
El planeta ya se enfrió
in a few years.
en unos cuantos años.
I mean, when the animal all die naturally, in a few years,
Quiero decir, cuando los animales mueran naturalmente en unos pocos años
and all the organic vegetable come in,
y todos los vegetales orgánicos crezcan,
few years time, we don't have any 2 degrees.
en unos cuantos años ya no tendremos 2 grados,
Yes.
2 grados, ¿sí?
Then we have the planet still.
Y entonces aún tendremos nuestro...
We can still keep the cars, train,
Todavía podemos tener carros,
airplane,
aviones.
until we develop better, greener technology for transportation, etc. You see what I mean? We still have all that, all the comfort.
Vean lo que me refiero, tenemos todavía todas las comodidades.
Yes, just stop the animal industry and become vegan. Due to climate change, more than 20 million have been displaced as climate refugees. Scientists also worry about the billions of tons of methane sitting beneath the now melting Arctic permafrost and the ever-warming oceans. Just a fraction released from either one could trigger mass extinctions.
Noble viewers, welcome to part 2 of our 3-part series, Warming Oceans, a call to end the climate crisis. In part 1, we learned how warming oceans are contributing to dangerously rising sea levels that threaten the lives of millions of people. In today's program, we'll discover how ocean warming is also adversely affecting marine life. One serious threat is the occurrence of marine heat waves. In early 2014, a massive volume of warmer than normal water began appearing about 200 kilometers or 125 miles off the west coast of the United States. The warming phenomenon persisted along the California coast and other parts of the Pacific during most of 2015 and into 2016. Seen on a monitoring screen as a monstrous red patch, the marine heat wave was dubbed the Blob by principal research scientist and Washington State climatologist Dr. Nick Bond. At its peak, the blob covered an area larger than the United States and resulted in massive algal blooms. Algal blooms are extremely dangerous to all forms of marine life. When waters become warmer, algae begin to grow profusely. As the algae die, the dead organic matter becomes food for bacteria. Then the number of bacteria increases dramatically, using up much of the dissolved oxygen in the water. This creates a dead zone in the ocean, where many plants, fish, and aquatic insects can't survive. In addition, heat waves in the ocean have other devastating effects.
When marine heat waves occur, they affect biology in a range of ways. Species change the location in where they live, and so, for example, in the Western Australian, many unusual species were pushed further south by the warm water. The warm water also killed habitats, and the bottom 2 panels on the left illustrate a before and after picture associated with the marine heat wave event. And similarly, on the right-hand side, examples of what happens to marine habitats in cooler water when they're hit by marine heat waves. You see loss of algae and loss of the animals that depend on those environments.
As a result of this heat wave, humpback and other whales began swimming much closer to shore off the coast of California in search of food. Here, record numbers of the animals became entangled in fishing gear. Some got ropes entwined around their mouths, making it difficult for them to eat, while others were caught in crab lines that slashed through their skin and caused infections. In 2016, more than 50 whales were either wounded or killed by fishing gear. Then, in August 2019, a second blob emerged off the coast of California, where a patch of warm water resembling a sea monster of record size was spotted. The heated-up ocean patch was approximately as large as the size of Canada. waters off the shores of Northern California, Oregon, and Washington hit a record-breaking 2.5 degrees Celsius or 4.5 degrees Fahrenheit above normal. Dubbed Blob 2.0, the patch will cause a range of damage to marine ecosystems. This warm water anomaly was reported in the April 2020 issue of the journal Nature Communications. Lead author Dr. Dylan Amaya, a research scientist at Scripps Oceanography, warned global warming shifts the entire range of possibilities towards warmer events. The Blob 2.0 is just the beginning. In fact, events like this may not even be considered extreme in the future. Marine scientists further warn that if climate change continues on its current trajectory, the world's oceans could lose many more sea organisms by the end of the century. We'll take a moment now to pray for the protection of all marine life forms. Please stay tuned to Supreme Master Television. Welcome back to Warming Oceans, a call to end the climate crisis. Recently, ocean heat waves have become increasingly common, threatening the existence of many types of marine life, from plankton to fish to whales, who dwell in the upper ocean zones where temperatures are rising more quickly than usual. According to a study published in the March 2019 issue of Nature Climate Change, between 1987 and 2016, the number of annual ocean heat wave days on the planet spiked by around 54%. The extreme rise in temperatures negatively affects sea life, including kelp forests, seagrass meadows, and coral reefs. These fundamental ocean environments provide food and shelter for countless marine organisms, including many species of fish. Thus, their destruction will have cascading consequences for marine biodiversity. Lead author of the study, Dr. Dan Smale, an ecologist from Great Britain's Marine Biological Association, writes, "You have heat wave-induced wildfires that take out huge areas of forest, but this is happening underwater as well. You see the kelp and seagrasses dying in front of you. Within weeks or months, they are just gone along hundreds of kilometers of coastline. Just as atmospheric heat waves can destroy crops, forests, and animal populations, marine heat waves can devastate ocean ecosystems." With increasing amounts of greenhouse gases being emitted into the atmosphere, the ocean is absorbing more and more CO2. When this happens, a chemical reaction occurs and the water becomes more acidic. Oceans are currently acidifying at a rate faster than at any time in the last 300 million years. Ocean acidification produces additional acidity-inducing chemicals while reducing important minerals such as calcium carbonate, which many marine organisms need to survive. One of the most serious consequences of acidification is that many deep-sea coral reefs are becoming brittle in the same manner that osteoporosis weakens bones in humans. As a result, the underlying structures of these reefs, which are home to a multitude of aquatic life forms, could fracture and break away. In addition, coral reefs suffer a stress response as ocean waters become warmer. When temperatures rise just 1 degree above their normal maximum, coral begins to bleach and die. A 2016 heat wave across northern Australia dramatically affected more than 90% of the Great Barrier Reef, leaving swaths of dead coral skeletons.
The biggest impact of climate change to coral reefs is due to increasing sea surface temperature. So as CO2 builds up in the atmosphere, the air and the water warms. And so we've actually already seen warming of about 0.5 to 0.7 degrees Celsius across the world surface oceans.
Rising temperatures throughout the global seas in coral reef ecosystems means the proliferation of more diseases. It means things like coral bleaching, the death of corals due to basically overheating, and then this notion of ocean acidification. These reef-building corals can no longer really build the hard structures due to this change in ocean chemistry.
The problem now is that there's so many of these different threats, and then you overlay the threat of climate change with the sea surface temperature increase, with ocean acidification. And the reefs are less healthy in general, and so it's harder for the reef then to recover from these other events or stresses. The biggest thing that we can do to stop the threat of climate change to coral reefs is to stop putting as much carbon dioxide into the atmosphere, to actually stop the warming we're seeing.
Rising ocean temperatures also affect the metabolism, life cycle, and behavior of many marine species. For some species, temperature serves as a cue for reproduction. For others, the water temperature in spawning areas significantly affects the success of mating and egg survival. A study by the Alfred Wegener Institute Helmholtz Center for Polar and Marine Research, published in the July 2020 issue of the journal Science, states that warming ocean waters could have a devastating effect on fish populations around the globe. The study predicted that climate change, if left unchecked, could negatively affect up to 60% of all fish species. Sea turtles are also vulnerable to rising ocean temperatures, as temperature affects the sex of their offspring. Research shows that if a sea turtle's eggs incubate below 27.7 degrees Celsius, the turtle hatchlings will be male. However, if the eggs incubate above 31 degrees Celsius, the hatchlings will be female. Rising temperatures would skew the sex ratios, thus threatening the survival of sea turtles. Many scientists report that climate change and its effect on ocean warming has become a critical issue. Dr. Dan LaFully, Principal Advisor in Marine Science and Conservation for the International Union for Conservation of Nature, says, "The world seems to be obsessing about what is happening on land and in the atmosphere, not realizing that life on Earth is wholly a subsidiary of the ocean that accounts for 98% of species on the planet." He further warns what was predicted back in 2004 as something we needed not to worry about until 2050 or 2070 is happening now. Supreme Master Ching Hai also frequently reminds us about the dangers of warming oceans and that the fastest way to stop climate change is through global adoption of the organic vegan diet.
Scientists have expressed concern, for example, that if the ocean waters continue warm, certain fish whose gender is determined by temperature might end up extinct because only one gender will be produced. Problems like this show the interconnectedness of life and the environment. To think that a small temperature change can actually change a female fish to becoming a male. This situation can change, yes. It can be reversed, but we have to act quickly for these and all the other imperiled lives in the ocean and on land. So please join, sir, and spread the vital messages. We all must be veg, go green, if we are to save the planet.
Over the last few decades, the world's oceans have been warming at a rapidly increasing rate. In parts 1 and 2, we learned about how warmer seas are decimating marine life and causing an alarming rise in sea levels. On today's program, we'll explore how ocean warming is contributing to extreme weather events. As ocean waters warm, evaporation increases, and when the resulting humid air interacts with weather disturbances, raging winds and unusually heavy rainfall can occur. Various climate scientists have shown the link between ocean surface temperatures and tropical storm intensity, with warmer waters powering more energetic storms.
Higher sea level and warmer temperatures may lead to more intense storms, such as hurricanes and typhoons. The theory is when there's a greater difference in temperature from the atmosphere to the oceans, it may lead to not an increase in the frequency of hurricanes, but more intense hurricanes.
Warmer waters in both the Gulf of Mexico and Atlantic Ocean have spawned some of the strongest storms on the planet. The warmer the water, the more chaotic and extreme the weather event will be. Supreme Master Ching Hai also told this in the conference, which took place in Orizaba on November 16, 2009.
Speaking of disasters in particular, the rising intensity and frequency of storms comes from the warming of the ocean, which changes weather patterns. This past decade saw several such devastating events, like Hurricane Mitch in 1998, which took the lives of nearly 20,000 Central American brethren, as well as Mexican fellow citizens.
One example of a storm getting a steroid boost from abnormally warm waters was Hurricane Michael in 2018. In just 2 days, as the storm moved across the Gulf of Mexico, it rapidly intensified into a Category 5 hurricane. With wind speeds of almost 260 kilometers per hour, Hurricane Michael became the most powerful hurricane on record to hit the Florida Panhandle. Similarly, it was reported that ocean temperatures fueled Hurricane Harvey in August 2017. As Harvey moved across the Gulf of Mexico, hotter than normal conditions supercharged the storm before it made landfall on the Texas coast. Hurricane Harvey caused more than 100 deaths, flooded hundreds of thousands of homes, and caused $125 billion in According to Dr. Kevin Trenberth, a distinguished senior scientist from New Zealand's National Center of Atmospheric Research, as climate change continues to heat the oceans, we can expect more supercharged storms like Harvey. Sea surface temperature creates altered atmospheric conditions that drive large-scale changes in weather patterns. Climate scientists are warning that warming oceans will contribute to even more severe weather disturbances in the future. During the summer of 2020, global ocean temperatures reached record highs, with sea surface temperatures being consistently 1 to 2 degrees Celsius above normal. In September, around the Gulf of Mexico, the Caribbean, and the coast of Africa, where many storms develop, these anomalies increased to 2 to 3 degrees Celsius above normal, as various countries experienced a record number of supercharged storms, cyclones, and hurricanes. On November 3, 2020, Eta, a Category 4 hurricane, ripped through the Central American countries of Honduras, Guatemala, and Nicaragua, killing dozens of people and causing massive destruction. Then, on November 16, 2020, Hurricane Iota, another Category 4 storm with winds of up to 250 kilometers per hour, struck the same nations, making landfall just 24 kilometers south of where Eta had struck. The torrential rains from these back-to-back hurricanes caused deadly landslides, flash flooding, and widespread destruction. Throughout Central America, the storms killed approximately 200 people, left an estimated 150,000 homeless, and caused billions of dollars worth of damage. In 2020, tropical storms and typhoons also battered many countries in the Pacific Ocean region. In August, Typhoon Hagupit hit eastern China, creating 4.0-meter high waves and causing 200,000 people to be evacuated. Less than 2 weeks later, severe tropical storm Makela struck the same area. Meanwhile, 3 back-to-back typhoons swept through the Korean peninsula in a span of just 2 weeks. In October 2020, Tropical Storm Linfa blasted Olac, also known as Vietnam, Cambodia, and neighboring countries, bringing heavy rainfall, landslides, and flash flooding. In Cambodia, more than 40,000 hectares of crops and paddy fields were destroyed by flood waters. In Olac, also known as Vietnam, Linfa was the 6th tropical storm to strike the nation in 2020, producing heavy rainfall and high winds. As of October 21, 2020, Linfa caused 114 people to lose their lives, 274,500 homes to be flooded or damaged, and an estimated 7 million people to be affected throughout the region. In late October 2020, Super Typhoon Goni, the strongest tropical cyclone in history, pummeled the Philippines, making landfall with winds of up to 310 kilometers or 195 miles per hour. The storm destroyed tens of thousands of homes, displaced more than 300,000 people, and killed at least 20 others. While ports and airports were shut down, the situation became even more difficult due to the global COVID-19 pandemic. Schools, gymnasiums, and government centers throughout the Philippines had to be turned into emergency shelters for evacuated COVID patients. In addition to wreaking havoc through tropical storms, warmer oceans are also playing a significant role in setting the stage for wildfires. Warm areas in the ocean can pull rain away from the land, causing drier conditions in surrounding areas and, in extreme cases, drought. In 2019, the Indian Ocean off the coast of Africa was exceptionally warm, causing heavy rainfall in the region. However, this shift pulled rains away from Australia, which consequently suffered a widespread drought. The year 2020 was marked by massive wildfires all around the globe. Australia grappled with the worst wildfire season in its history, which claimed the lives of at least 33 people, destroyed thousands of homes, and scorched approximately 18 million hectares of land. 3 billion animals were either killed or displaced. Also in 2020, a record number of devastating wildfires raged across California, USA. During the state's longest wildfire season in recorded history, a total of 9,639 rapidly spreading fires burned over 1.5 million hectares, more than 4% of the state's roughly 40.5 million hectares of land. Fueled by blistering heat, the wave of simultaneous blazes destroyed 10,500 structures and caused 31 deaths. In the neighboring state of Oregon, wildfires took the lives of at least 11 people and burned more than 400,000 hectares of land. Research scientist Dr. Katia Fernandez has shown that ocean temperatures play a critical role in setting the stage for wildfires. Dr. Fernandez developed an interactive mapping tool that shows the relationship between sea surface temperatures in the northern tropical Atlantic and wildfires in the Amazon rainforest. The warmer the water, the further north the rainfall is pulled. Regarding the 2014 to 2015 California heat waves and drought, climate scientist Dr. Daniel Swain says the last northeastern Pacific warm blob contributed to both drought and wildfire conditions in California. The impacts really can be devastating. Supreme Master Ching Hai frequently warns about the many dangers of climate change and recommends the quickest, most efficient solution: global adoption of the vegan lifestyle.
If we don't change our disaster-breeding provoking way, then disasters will never end. I'm also in tears whenever there is a natural disaster anywhere in the world. My heart aches for the suffering of the people. I feel what they feel, and I'm very, very much saddened. But we can only stop the disaster once and for all by tackling the root problem, that is, by stopping the killing of humans and mass murdering of innocent animal lives. Only when we walk in peace and love on this earth will the earth and nature respond peacefully to us. If we protect others, we will be protected.
Thank you, kind viewers, for being with us today. Coming up next is Jennifer Stojkovic, vegan, empowering female vegan entrepreneurs, right after noteworthy news. Through the grace of the divine, may you enjoy greater spiritual upliftment with every passing day.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/PE.